This second part talks about finding the nature of the stationary point, means what type of stationary points are there. So as we know in the first video, there are three types of stationary point. It can be maximum, it can be minimum, or it can be point of inflection. Now there are two methods of finding the nature of the stationary points. The first one is called the first derivative test, which means you find using dy dx, okay, and to determine what kind of stationary point is this. Now, from the previous example over here, when we do stationary point, remember the concept, it means dy dx equals to 0. I have 1 and 3 as my stationary points. And for convenience, I will write down what is dy dx over here. There will be 6, x minus 1, and x minus 3. The first derivative test is using a table, and I want to see, okay, on the left side of 1 and on the right side of 1, what is the tangent like? Okay, that's how I use the first derivative test. In the middle, I will always write 1. The sign of dy dx will be 0, and then the tangent will always be flat because at 1, I have a stationary point. So dy dx is 0 and the tangent is flat. Okay. On the left side, I write it as 1 minus. Okay. You can put a small bracket and like 0.9 because it's very close to 1 here. And then on the right side, I will have 1 plus, which is like 1.1. Okay, all I need to do is to sub in the value of 0.9 into my dy dx and see what kind of value I get. I do not need to know what is the value. I only need to know whether is it positive or negative. So I sub in 6 bracket 0.9 minus 1 as well as 0.9 minus 3. Okay, you will have a positive value, or you can just simply infer, because when you sub in 0.9 you will get negative, you sub in 0.9 here you will get negative, negative times negative, positive. Okay, when it's positive, the tangent is going up. Again, you sub in 1.1 into your dy dx, or you can just infer 1.1 minus 1, this is positive. 6 times a positive number, 1.1 minus 3 is a negative number, and then you will get a negative value. You don't need to know what is the value. Okay, so that's why we can say that we can do inference. When dy dx is negative, it will be going downwards. So what does this look like? This looks like an N-shaped curve. So I know that x equals to 1 is a maximum point. Okay, let's repeat the process for 3. So in the middle, I will write 3, 0, flat. On the left side, it is called 3 minus. The value I should put in is 2.9. And on the right side, it's called 3 plus. The value I put in is 3.1. Okay. Again, I sub it into my dy dx. Maybe for convenience, I will write my dy dx over here. 6 bracket x minus 1, x minus 3. When I sub in 2.9, into my dy dx, my dy here, this will be a positive value because 2.9 minus 1 as well, and then 2.9 minus 3 will be a negative value. So the sign of dy dx is negative, the tangent is going downwards. When I sub in 3.1 into my dy dx, this is a positive value, this is also a positive value. So this will be a positive value, okay, and my tangent is going upwards. Now this resembles a U shape, so I know that x equals to 3 is a minimum point. And that is how you use the first derivative test to find out whether the stationary point is maximum or minimum.